Hello, my name is Vanisha Parmar. I am from ICT department at Marwadi University, Rajkot. I have created this blog on optical spectrum in networking. This is part of my subject Introduction to Communication Engineering, which is guided by our HOD, Professor C.D. Parmar sir. So here in this blog I will explain you about optical spectrum and how it is important in networking. So basically we will see the optical networking, the role of optical spectrum in communication and networking. For that, let us see first what is optical spectrum. So it is right about the millimeter wave region is what it is, a optical spectrum. This region is occupied by the light waves. So there are three different types of light waves: infrared waves, visible waves, ultraviolet waves. Here you can see the optical spectrum. This whole region is occupied by the light waves. Thus it is called the optical spectrum. Optical means light and the spectrum suggests the form, in which form it represents. Let's see something about optical communication. So this is of NASA. You can see optical communication uses light as a means of transmitting information over long distances. Within the context of NASA, optical communication technology sends data across space using lasers instead of radio frequencies. You can see this laser light, the way this uses the laser. It does not use the radio frequency for communication technology. For data transmitting. So as above I said, laser communication mission. It uses infrared light to transmit information over long distances, and this technology sends data across space using laser instead of radio frequencies. This is said by NASA. So we will see in detail infrared light. What is infrared light and what is its use in communication? So mainly is used as infrared wireless communication. Infrared light is used in wireless network as it is very safe and secure with good speed. What does infrared wireless communication say? It makes the use of infrared waves in wireless technology for digital data transfer. Here, infrared waves belongs to the electromagnetic spectrum and it has slightly longer wavelength than visible light, which ranges from 750 nanometer to 1 millimeter. The frequency range of infrared is from 300 GHz to 400 THz. So infrared communication uses invisible part of electromagnetic spectrum, which is infrared rays. Infrared wireless network works for short and medium distance communication. The common application of infrared is TV remote control system. Here you can see this. This communication is done through infrared wireless network. Same with this. So for this infrared communication, two main things is there: infrared transmitter and infrared receiver. Infrared light emitting diodes, that are LEDs, used for transmitting infrared lights, and it passes through the lens and gets focused on the infrared beam. Focused as an infrared beam, then that infrared beam is source gets switched on and off rapidly to enable data encoding. Then about infrared receiver. Infrared enabled devices are called IRDA, that is infrared data association. The transmitted IR beam containing digital data is received by an infrared data association device that is equipped with silicon photodiodes. So, for further processing, the IR receivers convert the IR beam received to electric current. So, this was about infrared light, how it is used in wireless communication. Then we will see about visible light. So, visible light and how it plays its role in communication. Visible light communication, shortly named as VLC, it is a wireless method that uses light emitted by the LEDs to deliver networked mobile high-speed communication similar to Wi-Fi. So it uses what light emitted by the LEDs. And the visible light spectrum is 10,000 times larger than the radio frequency spectrum. Visible light communication is regarded as a solution to RF bandwidth limitation, that is radio frequency bandwidth limitation, so that industry has generated very high data transmission rate, making it competitive. Though a signal cannot penetrate obstructions such as wall, a direct line of sight is not required as long as light is reflected from other surfaces. The LED light must be on for this signal to transmit, but can be dimmed to very low levels. So, visible light communication has an advantage over Wi-Fi in that transmission does not causes electromagnetic interference. Here you can see in this picture visible light communication, which is between LED, air conditioners, LED lamps, other devices also like computer, this printer, laptop, TV, etc. And here also the light which is emitted from LEDs, it uses by the visible light communications here, and then it sends the data to the particular devices. Then let us see about ultraviolet light. So still now ultraviolet is not being used in communication, just there are research going on this, that ultraviolet communication uses invisible rays that are part of energy that comes from the sun, and ultraviolet radiation that reaches the earth's surface are called UV lights. So these UV lights falls in the range of electromagnetic spectrum between the visible light and X-rays. Its frequency is about 8 into 10 raised to 14 to 3 into 10 raised to 16 cycles per second, or hertz we can say, and its wavelength is about 380 nanometer to about 10 nanometer. So basically UV communication shows great potential in replacing traditional wireless communication in more and more scenarios. So research upon this is going on based on atmospheric scattering of UV radiation. UV communication has gained considerable attention due to its non-line of sight ability and omnidirectional communication links, and it shows the low background noise. So this advantage makes ultraviolet communication an ideal option for convert to secure communication, especially for the military communication. So this was all about optical spectrum in networking. Let me show you the reference pages. So these are the references from which this content has been taken. Thank you.